Hi, this is Alex from devstories.eu. LangChain v1.0 Orchestration Framework, episode 17 of 20. You do not need to load your agent's brain with every possible scenario up front. Sticking 50 pages of instructions into a single system prompt just makes your model confused, slow, and expensive. You just need to teach it how to ask for the right manual when the time comes. This is the core mechanism behind state-driven agents. State-driven agents operate on a simple principle. Agent behavior changes dynamically based on the current state of the application. We handle this using two main patterns, which are skills and handoffs. Both patterns rely on tools to update state variables, which in turn dictate what happens next in the workflow. Let us look at the skills pattern first. This pattern is about progressive disclosure of knowledge. Instead of giving an agent all its instructions at the start, you give it a tool. When the agent decides it needs more information to solve a problem, it calls this tool. The tool executes, but it does more than just return a string to the model. It updates a specific state variable in your application. Your orchestration layer monitors this state. When it detects the change, it dynamically injects a new set of instructions or capabilities into the agent's system prompt for the very next turn. Take a standard customer support agent. Initially, its only job is to figure out what the customer wants. A user asks about a broken product. The agent calls a tool to collect a warranty ID. The execution of this tool updates a state variable to indicate a warranty claim is active. The application reads this new state and dynamically loads a specialized refund skill into the prompt. This skill might include the specific rules for processing returns and access to a secure inventory database. The agent's capabilities evolved mid-conversation, driven entirely by a state update. Now, what if the required task is too complex for the initial agent to handle, even with new skills? That is where the handoff pattern comes in. Handoffs also use tools to update state, but instead of loading new instructions into the current agent, the state change transfers control to an entirely different agent. Back to our scenario, the support agent collects the warranty ID, but instead of processing the refund itself, it calls a handoff tool. This tool updates a routing variable in the state, changing the active agent from the triage bot to a specialist agent designed solely for high-value returns. The orchestration layer sees this state change and directs the next step of the workflow to the specialist. This transition point is where things often break down. When handing off between agents, the new agent needs the context of the conversation. Many developers try to clean up the history by just passing the raw user messages to the new agent. Do not do this. When handing off between agents, you must include the AI message containing the actual tool call that initiated the handoff and the resulting tool message that acknowledges the handoff occurred. If you drop the tool call and the tool message from the message array, the conversation history breaks. The new model loses the logical chain of events. It won't know how it got there, and it will likely repeat questions the user already answered. Always pass the unbroken message history. Here is the key insight. The state is not just a passive memory store, but the control plane that dictates exactly what your system is capable of doing at any given millisecond. That's all for this one. Thanks for listening, and keep building.